Friends, welcome to my channel VK Voice. So today we are going to discuss pulley. What is pulley? First of all, I will discuss with you what is pulley. For demonstration, I am having something. Let me show you. And here I am having a pulley is a metallic or wooden disc which have grooved rim. Metallic or wooden disc which have grooved rim. And this disc is capable of rotating about a axis, and through this axis an axle is passing like this. Axle is passing like this, and this axle is fixed in a frame, and a rope is passing over the rim. The whole arrangement I have shown in the diagram as well. Here you are having a pulley, a disc, and here you are having that frame. Here this is the axle over here, and you are having load, you are having this string which is passing over it. So this is nothing but a pulley, a metallic disc or a wooden disc which is having grooved rim, and a axle is there which is fixed in a frame. That is called a pulley. Now today I am going to discuss with you a single fixed pulley and a single movable pulley. Two types of pulley I am going to discuss with you. First of all, before I discuss this single fixed pulley or single movable pulley, I will just want to discuss with you one term, and that term is if you are having a single pulley or if you are having a combination of pulley, single or combination of pulley, that is known as block. Single or combination of pulley is known as block, and the string or the rope which is passed over this is known as tackle. String or rope which is passing over this is known as tackle. Now next thing is single fixed pulley. What is a single fixed pulley? As the name suggests, fixed. What is fixed over here? Its axle is fixed. Single fixed pulley is that pulley whose axle is fixed in its position. This axle will not move up and down. It will remain where it is. It will remain fixed over here. So this is a single fixed pulley. Now how it rotate, how the rope rotate the pulley. This is also important, how the rope rotate. There is a friction between the surface of the rim and the rope, and this frictional force is responsible for the rotation of the pulley. Frictional force is responsible for the rotation of the pulley. Now let us see how it functions, what will be the mechanical advantage, what will be the velocity ratio, and what will be the efficiency in this case. So first of all, as I have shown over here, a diagram is there. Load you can see is over here, effort you are applying over here, and in the balanced position, load you can see load is equal to tension. So load is equal to tension, and also effort is equal to tension. Effort is also balanced by tension. So from here what you get, effort is equal to load. From this and this you can easily see L is equal to T, E is also equal to T, therefore E is equal to T. Effort is equal to load. Now keep it in your mind, in case of single fixed pulley, the effort applied is always equal to the load which we are to lift. Effort and load are equal. For example, if you want to lift a body of weights for 10 newtons, then you will have to apply the same force. The effort will also be 10 newton. But this is the case when the pulley is a ideal pulley. Otherwise you will have to apply more force. You know, there is a friction in the axis also, in the axle also. Due to this friction, the effort required will be more. So in actual, effort will be more, but in ideal condition, effort is always equal to load. Now what will be the mechanical advantage? You know, mechanical advantage is equal to load upon effort. Load is T, effort is also T. Therefore, mechanical advantage is 1. Now, when you pull this string in the downward direction, if it is pulled through a displacement d by the effort, thus in the same displacement the load will move in the upward direction. That means if the displacement of the effort is d, then the displacement of the load will also be d. And you know, velocity ratio is the ratio of displacement of effort to the displacement of load. Displacement of effort is d, displacement of load is also d, therefore velocity ratio is 1. And you know, there is a relation between mechanical advantage and velocity ratio. You know, efficiency is equal to mechanical advantage by velocity ratio. Mechanical advantage over here is 1 and velocity ratio is also 1. Therefore, efficiency is equal to 1 or 100%. So, keep it in your mind that efficiency of a single fixed pulley is 1 or equal to 100%. But here also, this result is valid for ideal pulley. In actual, as I have told you, effort is always greater than load. Therefore, mechanical advantage will be less. Since mechanical advantage is less, therefore efficiency will be less in case of actual device, actual machine, actual pulley. So this result is for the ideal pulley, not for the actual pulley. For ideal, efficiency is equal to 1 or 100%. Now here you have seen that mechanical advantage is 1 and velocity ratio is also equal to 1. Mechanical advantage is 1, that means it is not greater than 1. Therefore, it is not acting, the pulley is not acting as force multiplier. And similarly, velocity ratio is also 1, it is not acting as a gain in speed. So, single fixed pulley is not acting as a force multiplier, nor it is acting as a gain in speed. Then the question is, why then we are using this single fixed pulley? Now we are using this single fixed pulley only to change the direction of effort. To change the direction of effort. So if someone asks you why we are using a single fixed pulley, to change the direction of effort only. And its one benefit is that you can include the weight of the body also in the effort. When you are just pulling it down, you can use your weight also. So it will be easier for you. Your effort will be more because weight is also included in the effort. So this is there about the single fixed pulley. I suppose up to here this is clear to you. Now let us start the next thing, and that is movable pulley. What is movable pulley? As the name suggests, its axle can move up and down, or you can say its axle is not fixed. So that pulley whose axle is not fixed is known as movable pulley. Today I am going to discuss with you about the movable pulley. Here you can see, this is very important. Here the load is supported by two tensions, and this tension and this tension. So you can write that load is equal to T plus T. Two tensions are there, or you can write 2T. And in the balance position, you can see effort is equal to tension. Effort is equal to tension. Therefore, if I apply this result over here, I will be having effort is equal to load by 2. That means you will have to apply half of the load. Your effort is half of the load. For example, if the load is 10 Newton, you will have to apply the effort equal to only 5 Newton. So effort applied over here, effort required over here is half. But again, this is there only in case of ideal pulley. But if the pulley is not ideal, then the weight of the pulley will also be included and the friction will also be there, and due to which effort required will be not equal half of the load, but it will be more than that of half of the load. So next thing which we are going to discuss is, now what will be the mechanical advantage in the case of movable pulley. You know, mechanical advantage is load upon effort. Load over here is 2T. So I will write 2T upon effort over here is T only. So T. So you will be having 2. So mechanical advantage in case of movable pulley will be 2. So from this result, mechanical advantage is greater than 1. That means this pulley will act as force multiplier. You will have to apply less effort to lift the load. This is the advantage of the movable pulley. Now what will be the velocity ratio? Velocity ratio. Here, for velocity ratio, see the diagram over here. If the effort move through a displacement 2D, the load will move through a displacement D. Why? Because these two sections covers equal displacement. Therefore, displacement of effort is 2D, displacement of load is D only, and velocity ratio, as you know, is displacement of effort by displacement of load. 2D divided by D, you are having 2 only. So the velocity ratio of this pulley is 2. Mechanical advantage was 2. Velocity ratio is also 2. And you know, efficiency is mechanical advantage by velocity ratio. Mechanical advantage by velocity ratio. So 2 divided by 2 is equal to 1 or 100%. So efficiency is 100%. Again, this is the case when the pulley is ideal. If the pulley is not ideal, in that case, this efficiency will not be equal to 1, but it will be less than 1 only. So student, I suppose you have understood whatever we have discussed today. And last time I asked a question from you. Most of the students answered, but they have answered without mentioning their name. So please mention your name as well, and after I receive the names, then I will announce your name here only. So I am not asking the question today. I will just, first of all, I will announce the names in the next video, and then in the same video I will ask a question also. Thank you for watching my video.